Welcome back to another exciting chemistry lesson. In the previous lesson, we learned about molarity as a conversion factor between mole and liter of solution. Now, in this lesson, we are going to look at molarity as an equation, and that is capitalized M equal to mole over volumes, okay? So we are going to look at this and we can determine any of the variables in this equation. Because it is an equation, we can rewrite this and separate the variable that we want to solve for. So for example, if we want to solve for volume, we can have that volume is equal to, we could switch between here, volume is equal to mole divided by molarity. Or we can solve for mole, okay? If that's the case, I need to bring this over here. So mole is equal to molarity times volume. See how that works? Let's do an example problem. We have 300 milliliter of 0.5 molarity of calcium chloride. And this aqueous, that means being dissolved in water, is added to 600 millimeter of distilled water. So this distilled water is basically pure water, H2O, okay? What is the concentration of chloride? Okay, so we're now looking at our chloride ions. And remember, very tricky because chloride, there are two chlorides in calcium chloride. In the resulting solution, assume volume are additive. That means you just add the volume together. So if we look at this problem, we have first thing first, we had to solve for a particular part of molarity. First of all, we need to figure out the mole. And we figured out the volume. Well, volume is very straightforward. Volume here we have what? 300. So molarity is equal to mole over volume. And we figured out that volume is additive. That means 300 plus 600. But one thing we have to realize, this is in liters, right? So we divide them by 1,000 to get ourselves in liters. So in this case, 0.3, 0.6. So our volume is equal to 0.9, okay? 0.9 liters. That's pretty easy. The part that's really tricky is the mole part. Well, first of all, we cannot solve for chlorine directly from molarity. We have to solve for calcium chloride first. So to do that, to figure out mole, right? Mole is equal to molarity times volume. So this is mole. For example, in this case, is moles of calcium chloride. So I'm going to put mole calcium chloride equal to what? Molarity times volume. So in this case, we have 0.5 times your volume, which is what? Well, the volume is this one right here. So it's 0.3. We're not using 0.9 because 0.9 have the still water in it. We're using the volume of this solution. So what is that going to give us? 0.5 times 0.3 is equal to 0.15. There you go. But this right here is your moles of calcium chloride. But what we want to solve for is chloride by itself. So now we just use a basic mole ratio. And that is pretty easy. All we have to do is using mole to mole ratio. Well, 1 mole of calcium chloride, and this is equal to 2 moles of chloride ions. That is 2 chloride in calcium chloride. See that? Now this cancel out, give us what? 0.15 times 2 give you 0.3 mole of chloride ions. And that's how this is a little bit tricky because now we're involving question to have mole ratios in it, okay? So let's look at this. So we cannot solve using molarity as a conversion factor directly because we're looking at part of a specific compound. Now to determine in terms of molarity, going back here, so now we know the value is going to be 0.3 moles. Okay, so now we have to do is plug it in, 0.3 mole divided by 0.9, and that gives us what? And the answer is 0.33 molarity of calcium chloride. And that's how we use molarity as an equation to solve for the concentration of specific ions in a solution. Let's try another problem. If the values of sodium ions is 2.0 times 10 to the negative 4 molarity, calculate the minimum volume of distilled water in liter necessary to completely dissolve 4 grams of sodium fluoride at 298 degrees Kelvin. The molar mass of sodium fluoride is 42 0.00 gram per mole. Now let's look at this again. Again, we have molarity. We have to use this as an equation. The first thing first we have to always determine is that molarity is equal to mole over volume. And now we are focused on volumes, okay? So in this question, we are looking for volume. But do we know anything about other variable? Well, we know about the concentration. Yes, right there. Do we know anything about mole? We don't have mole, but what do we have? We have grams right there. Well, what we can do is we can convert gram to mole. That's pretty easy, right? So pretty straightforward. We have 4.0 grams of sodium fluoride right there. And we are given the molar mass, which in this case is 42 grams per mole. So if that's the case, so we have 42.00 grams of NaF, okay? And this is 1 mole of NaF right there. This gram cancel out. And all we have to do is now we can get our mole very easily. So we take 4.0 divided by 42.00 and plug in a calculator, we have 0.952 mole of sodium fluoride. And there you go, we have a mole. And all we have to do now is to solve for V, which is pretty easy. We bring this over here and we bring this down there. So our V is equal to mole divided by molarity. And we just plug it in. 0.0952 divided by 2.0 times 10 to the negative 4. If you plug this in your calculator using an online calculator, again, you can use the EXP right there, okay, or the E button. Now, with that information, we can now solve for it. So what you have to do now is just plug in a calculator. And plug this in our calculator, we have 476 liters of distilled water that need to be added into 4 grams of sodium fluoride to make this small concentration. As you can see, this is very, very diluted. This is 10 to the negative 4. And that makes sense because you are trying to make a very small or very diluted solution. Look at this, this 10 to the negative 4 is very small. So of course you would need to add in a lot of water given the sample of mass right there. Now let's try another problem. Determine the mass of magnesium sulfate decahydrate, and given that the molar mass is needed to prepare 500 milliliter of 0.2 molarity magnesium sulfate. And before we start solving this problem, magnesium sulfate is basically, again, MgSO4 right there. That's magnesium sulfate, which is this part right here. So if you look at this right here, there's 1-to-1 ratio. 1 moles of magnesium sulfate is in 1 moles of magnesium sulfate decahydrate. So when we look at this, it looks like very tricky, right? But it's not. You just have to look at in terms of, again, the mole to mole ratio. So all you have to do is you have to realize that the moles of magnesium sulfate is equal to the mole of magnesium sulfate decahydrate. Okay? So just keep that in mind as you are trying to solve for this. So again, going back to molarity, molarity is equal to mole over volume. Do we know anything about the molarity? Yes, we do. Right there, it's given to us. Do we know anything about the mole? No, for now, no. But do we know anything about the volume? Yes, there you go. Just make sure this has to be in liter, right? Which we divide by 1,000, so it's 0.5 liter. So now can we solve for mole? Yes, mole is pretty easy. We bring this over here. So mole is equal to molarity times volume. And we know our molarity is 0.2. And we know our volume is 0.5. What is that going to give us? Well, in this case, it's going to give us 0.1, okay? So 0.1 moles of magnesium sulfate. And that is equivalent to or equal to 0.1 moles of magnesium sulfate decahydrate. Isn't that nice? That's the beauty of knowing how to read a chemical formula and look at in terms of ratio. And now to convert from mole to mass is pretty easy because we have our molar mass right here. So all we have to do is multiply by our molar mass. So this is mole, so we have 1 moles of magnesium sulfate decahydrate. Notice I show you all the work, okay? And then this is equal to, on top will be 246 grams of magnesium sulfate decahydrate. And notice how the mole cancel out. So if that's the case, if we multiply by 0.1, we just move the decimal over. And therefore, we have 24.6, or you can plug in the calculator, your choice. 24.6 gram of magnesium sulfate decahydrate. And as you can see, this is a lot different than using molarity as a conversion factor, as we are solving for specific things in a specific compound or in terms of specific variables, either volume or moles. And then also we're talking about adding water or how much water is needed. And that's what makes this more challenging than just using molarity as a conversion factor. And again, if you have any question, take a picture of your work, put it in the forum, and we will try our best to help you from there. And we will see you next time on another exciting chemistry lesson.